Okay, these problems are about distance, rate, and time problems. So what we're going to need to know is we need to know that distance always equals rate times time. So in this case, we have an airplane that's going with the wind and against the wind. So if the plane is going with the wind, then the wind is going to push it up and it's going to make it go faster. If it's going against the wind, then the wind slows it down and it's going to go slower. So what I'm going to do is I am going to make a table. And in this table, I'm going to try to put the distance, rate, and time for this plane in two situations. The first situation is when it's going into the wind, and one when it's going with the wind. Now, in this problem, what we're trying to find is we're trying to find the speed of the plane if there were no wind. So I'm going to call that x. So x is going to be the speed of the plane in still air, is what they say a lot of times. This would be x. And then I'm going to call y the speed of the wind. You might also encounter problems in this section about a boat going with the current and against the current. It is basically the same exact problem. Now it says it flies with the wind or against the wind into the wind. It travels 4,500 kilometers in 6 hours. So I know this is 4,500 in 6 hours. And when it's going with the wind, when the wind is speeding it up, it goes 7,490 kilometers in 7 hours. Now the trick here is we don't know the rates, but what we're going to do is we're going to figure out the rates based on these two variables. So if you're going into the wind is slowing your speed down. So you have your normal speed you're going, which is x, and then the wind is slowing you down a certain amount. So the rate against the wind, into the wind, is x minus y. It's your normal speed minus whatever the wind is. And same thing if you're going with the wind, it speeds you up, so our rate is going to be x plus y. So this table is really valuable when you're doing these distance, rate, time problems, just to find out what your distance, what your rate, and what your time is. And now I can make two equations because I know from up here, distance equals rate times time. So distance equals rate times time. So my two equations are going to be 4,500 equals 6 times x minus y. I did time times rate just to make it a little nicer, but you don't have to do that. And then I have 7,490 equals 7 times x plus y. Now, one thing you can do is you can distribute right now and kind of solve the system of equations, but there's a trick in ALEKS problems like this. It's pretty common. What you can do is I'm going to divide this first equation, I'm going to divide both sides by 6. And this equation, I'm going to divide both sides by 7. Almost all the time, this will work out to be a nice number and it'll make my equations much easier. So 4,500 divided by 6 is going to be 750 equals x minus y. And 7,490 divided by 7 is 1,070 equals x plus y. So really this problem boils down to solving this system of equations right here. I have to solve for x, I have to solve for y. So there's a couple of different ways we can do this. We can do substitution, we can do elimination. I think the easiest way is to probably do substitution because you can use it on more problems. So what I'm going to do is I'm going to take one equation, I'm going to take the first equation, and I'm going to get one variable by itself. So I'm going to get the x by itself. So if I get the x by itself, it would be 750 plus y. Because I'm just adding y to both sides to move this y over there. That gets x by itself. Why this is beneficial is now that I have x by itself, I can replace x in the second equation with whatever I got in the first equation. So since x was 750 plus y, I can replace that into the equation. I know the ALEKS tells you use the graphing calculator. I find that to be a very, very bad idea. If you do a substitution or elimination, it will work much, much easier. So we will end up with 1070 equals 750 plus y, that's what I substituted in for x, plus another y. So this was my old x in the second equation. So now I'll just go ahead and solve. I get 1070 equals 750 plus 2y. I'll subtract 750 from both sides. So 1070 minus 750 is 320. So 320 equals 2y. And divide both sides by 2. So y will be 160. So what is y? Y is the speed of the plane is the speed of the wind, pardon me, because that's y. So this answer is going to be 160 kilometers per hour. And so that goes right here in my Alex. So the second part is I have to find x, because I want to find the speed of the plane in still air. So what I'll do is I'll take either of these two equations, or I could actually take this equation right here, because I know x equals 750 plus y, but I know y is 160. So it's just 750 plus 160. So that's going to be 910, I believe. So 910 is x. That is the speed of the plane in still air, kilometers per hour. So setting up this equation or this table to get the equations will make the problem a lot easier.